Module 4.2 starts to look at creating structures of data in the C programming language. So when we were talking about static arrays, we saw that an array holds multiple variables of the same type, like holding a list of the same type of variables. A structure is a little bit more generic. It holds a collection of variables, but those variables can be arbitrary types. So in particular, anytime we have a collection of variables that we want to use together to describe something at a higher level of abstraction, it might make sense to store them together in a structure. And this is starting to look a little bit like an object and object-oriented programming, except it's just the member data of an object, if you're familiar with object-oriented programming. So a structure can have any number of named members, and each of those members can be of whatever type we want to have. And the structure itself will be a variable, and we can access the variables inside of it, which are called the member variables, using the member operator, which is a period. So the way we define a structure in C is to use the keyword struct. So structures are often called structs. Struct is essentially a way to define a custom type, and the type is going to include the keyword struct along with a given type name. So just like an enum, where we had the enum keyword plus the name of our enumeration, the type of a struct is going to include the struct keyword and the type name. So as an example, we're going to create a data structure to represent a car. We're going to create that with the struct keyword and the type name car, and its type is going to be struct car, both words. So here is that example. We're going to start by creating a simple struct that represents a car with some of the defining characteristics of a car. If you think of a car, some of the defining characteristics are: what are the make and the model of that car? What year, what is its model year? What year was it manufactured? And what color is it? Of course, we could go into a lot more detail than this, but we're going to keep this nice enough to be useful, but relatively simple. So we're going to start by declaring our struct car, as having the make be a string with maximum length 16. The model will have maximum length 32. The year is going to be an integer. And the color is going to be a string of maximum length 16. Now, these numbers clearly won't work for all possible makes, models, and colors of cars, because some makes, models, and colors are more characters than that. But this is just what we're going to use temporarily. Now, when we want to create an instance of our struct, we can do that in a lot of different ways. One way that we can do this is we can, just like we could define an array by giving a list of its elements, we can instantiate a struct by giving it a name and a list of all of its elements. So here, struct car is our data type. My car is the name that I'm giving to this variable. MG is the string representing the make. MGA 1500 is the model. 1958 is the year, and red is the color. This is a valid way of declaring and defining a struct car data structure. These string literals will be copied into the make and model and color variables within the struct, and this integer will be copied into the year within the struct. Now, when we want to access or we want to read the values from within the struct, we can do that using the dot or period struct member operator. So if I want to print a string that describes my car, I can give the printf function with a format string to print string, integer, string, string. And it's going to print these in the order of mycar.color, which is accessing the member variable called color within the struct called mycar, the year, the make, and the model. So when I run this, it should say my car is a red 1958 MG MGA 1500. That's not true. That's a beautiful car. I don't own one. But this will work. This is how we create struct data and access the contents of struct data. And this is relatively straightforward. If we want to go a step farther, we can actually create our own alias if we don't want to have to type struct car every time we create a new car. So we can use our typedef keyword that we talked about in module 4.0, and we can typedef struct car into an alias. So we're going to create an alias called car underscore t. And car underscore t is intended to stand for car type. That's our type. So now, the way that we do this, again, when we use typedef, we say the keyword typedef, the existing type, and then the alias that we're creating. So these 6 lines of code are actually doing a whole lot of things. They're declaring the 3 static string entries and the integer entry into a new struct called struct car. So struct car also becomes a valid struct type. And we're also creating the alias car t at the same time. That's an important thing to note. We could still use struct car just like we can use car t. These are both now valid types. So now when we create our car, when we create my car, instead of saying struct car my car equals all of this, I can say car t, my car. And it just looks a little bit more clean with our custom type. And now we can use this custom type just like we can use any other primitive type in C. And then, of course, we can do more interesting things. Now that we have our custom struct type and we know how to create static arrays, we could actually create a static array of cars. In other words, we can build a virtual garage with our favorite cars. So in this one line of code, albeit one very, very long line of code, I can actually create an array of length 4 where each entry in the array is a car struct. And in this one line of code, I have populated the make, model, year, and color of all 4 of those cars. So now this is a very simple way of defining a custom type and demonstrating that we can treat this custom type just like we can treat any other type in C, any other static type, where we can create arrays of them, we can populate arrays of them, even though it starts to look relatively complex, where now we have a array being constructed as a list of structs, each being constructed as a list of strings, each of which is a list of characters. So yes, this is a list containing lists containing lists. And it's complex, but at the same time, it's very concise and it's relatively easy to understand. Relatively easy to understand. It's not a ton of code, it's not a ton of complexity, but it's a fairly detailed data structure, and now we have a lot of capabilities in what we can do with that. So let's jump to a terminal quick and look at this exact example. Let's clear the previous one. So let's look at the car.c file. So this starts off with this exact code. In my main function, I'm defining the car t data type here. I'm then defining my one car, like we did previously, and printing my car is a red 1958 such and such from the previous example. We then have the one line of code defining the entire super fancy 4-car garage, and then showing that we can go into that garage, access one particular car, and print the details of that car as well. Just like we can with the single car, we can go in and print the details of the last car in the garage. So this is now what is inside of this file. When we run this, what we hope to see is two print statements for two different cars. One, the my car object, and one, the final entry of the garage, which should be the blue Maserati Spider. So let's compile this. And once it's compiled, let's run, and we can see that that is exactly what it prints. The first print statement for the red 1958 MG, and the second print statement for the blue 1962 Maserati. Both beautiful cars, neither of which I own. So, going back, we've now seen how we can construct some really nice things using these struct, the struct keyword, as well as combining that with static arrays, and we can start to do some really nice things. By the way, we're going to continue to build off of this car example throughout the rest of the course. We're going to use this and we're going to modify this a number of times as we go on. So next, now that we have arrays and we have structures, we're going to move into defining our own operators, which we do through functions.